Hello students, good morning and welcome. Today we discuss the very important topic in inorganic chemistry, that is chelates and their applications. Myself, Dr. D.M. Chavan, Assistant Professor in Chemistry, Indira Madhyalekwan, District Yavatmal. Dear students, Alfred Werner first introduced the such type of complex formation, but the concept of chelate was proposed by Morgan and Drew in 1920. The ring formed by the union of metallic atoms and organic and inorganic molecular ions. Such rings are called chelates and the phenomenon is known as chelation. Dear students, the word chelate derived from the Greek word that is chill or chillos means crab's claw. We know that the crab pick up the food with the help of claws. Similarly, organic or inorganic molecular ion pick up the metal with the help of donor hooks. Dear student, this is the picture of crab. This crab pick up their food with the help of these claws. Similarly, the organic ion or inorganic molecular ion pick up the metal atom and form the ring. Let us consider the example. Suppose this is the cadmium. Cadmium is the central metal ion and ethylene diamine is the ligand. These two ligands of ethylene diamine pick up this cadmium metal ion by forming the coordinate bond with the help of donor atom. This ethylene diamine have the donor atom NH2 group. The lone pair of electrons present on the nitrogen atom forms the coordinate bond with this cadmium metal ion and form the ring. This is known as the chelation. Similarly, as the cadmium have the 4 valency and the two ligands can form the 4 bonds with the cadmium and form the chelate ring. This is known as the formation of the chelate. And ethylene diamine is the chelating agent, is the central metal ion, and the phenomenon is known as the chelation. Now, what is chelate? A chelate is formed by the reaction between metal ions and substance containing electron donating groups results the formation of one or more ring. Example, suppose M is the metal and this is the ligand. Such types of ring is formed by the reaction between the ligand or the chelating groups and the metal ion. Similarly, this is the another examples of the chelate formation. Now, classification of chelates. The chelates are classified on the basis of number and kind of attachment of ligands to the central metal ion. Chelates are of two types, that is covalent bond forming and coordinate bond forming. Two types of bonds are formed between the central metal ion and ligand. Some ligands have the groups which can form only the covalent bonds, and some ligands have the groups on the ligands, they can form the coordinate bonds. The covalent bond forming groups present in the chelating agents are carboxylic group, sulfonic group and enolic groups. These groups can form the covalent bonds with the central metal ion. NH2 groups, oxime groups and carbonyl groups have the tendency to donate the lone pair of electrons and form the coordinate bonds with the central metal ions in the chelate formation, chelation process. Now we discuss the bidentate chelating groups. Dear students, we know that on the basis of the number of bonds formed by the chelating groups, the chelating groups are classified as bidentate chelate, tridentate chelates, quadridentate chelates and hexadentate chelates. Now we discuss the bidentate chelating groups. Suppose these chelating groups have the tendency or it can form only 2 bonds with the central metal ions, therefore it is known as the bidentate chelating group, because bi means 2. There are 3 different types of bidentate chelating groups. First is the 2 acidic groups combined through the covalent bonds only. Suppose this is the examples Here, these ligand or chelating groups can only form the covalent bonds with the help of the oxygen atoms. This is the oxalate chelating groups or oxalate ligand. The lone pair of electrons present on these oxygen atoms, they can form only the covalent bonds. Means there are the two acidic groups present on these chelating groups. Then another bidentate chelating groups is the one acidic and one coordination bond forming groups. Example is the glycine. This glycine can form the covalent bonds with the help of the oxygen donor atoms and coordinate bonds with the NH2 donor atoms. Therefore, such bidentate chelating groups are known as one acidic and one coordinate bond forming chelating bidentate chelating groups. Then third example is the two coordinate bond forming group. Example is the phenanthroline. Phenanthroline can form the two coordinate bonds with the Fe atom. Therefore, this is the bidentate chelating groups having the two coordination groups, or it can form the two coordinate bonds with the central metal ion. Now we discuss the tridentate chelating groups. Dear student, tri means three. If any chelating groups, if they are formed the three bonds with the central metal ion, then such chelating groups are known as the tridentate chelating groups. These tridentate chelating groups are of four types. First is the three acidic groups containing tridentate chelating groups. This is the example of this ligand. This ligand can form the three covalent bonds because there are the three acidic groups present in the tridentate chelating groups. Then another example is the one acidic and two coordinating groups. These NH2 groups can form the coordinate bonds and this acidic group can form the covalent bonds. Therefore, this tridentate chelating group is the one acidic and two coordination bond forming tridentate chelating groups. Then third example is the two acidic and one coordinate bond forming chelating groups. Here, this is the example. It can form the two covalent bonds with the oxygen and one coordinate bond with the NH2. Then next is the three coordinating groups. Here there are the three donor groups. That donor groups can form only coordinate bonds, and this is the tridentate chelating groups having three coordinating groups. These are the various examples of tridentate chelating groups. Now we discuss the quadridentate chelating groups. Now we discuss the quadridentate chelating groups. Dear students, if any ligands, they can form the four bonds with the central metal ions, then that chelating groups is known as the quadridentate chelating groups. These are of three types. First is two acidic and two coordinating groups. Here there are two coordinate bonds are formed with the help of the NH groups and two covalent bonds formed with the help of this acidic group present, that is oxygen atoms. Therefore, this quadridentate chelating groups is known as two acidic and two coordinating group. Then another example is the four coordinating groups. Here, with the help of this nitrogen, they can form the four coordinate bonds or four coordinating groups. Therefore, such chelating groups is known as four quadridentate chelating groups. Then another example is the two covalent and two coordinating group. Here this is again example of two covalent and two coordinating groups. They can form two covalent bonds and two coordinate bonds with the copper central metal ions. The next is the hexadentate chelating groups. Any chelating groups, if they can form the six bonds with the central metal ions, then such chelating groups are known as the hexadentate chelating group. This is the ethylene diamine tetraacetic acid, that is known as the EDTA. This EDTA can form the six bonds with the central metal ion. Therefore, this is the hexadentate chelating group. These are of two types, that is two acidic and four coordinating groups. This is the example. Here, with the help of this oxygen dominant atom, they can form the two covalent bonds, and with the help of nitrogen and sulfur, they form the four coordinate bonds. And this chelating group is known as hexadentate chelating groups. This is the another example of the hexadentate chelating groups. Now, what are the applications of the chelates? The chelates are used, or one of the most important of these chelate is as a precipitating agents. Then qualitative detection of the metal ions in any samples, use the chelates. Then removal of interference in gravimetric estimations, the spectrophotometric estimation of trace quantities of metal ions, then solvent extraction and separation of metal ions through complexation. These are the various important applications of chelates. Thank you students. Thank you for watching my video. Thank you very much.